In this presentation, we're going to look at how we can define meaningful change or real changes between an athlete's test scores. So they test at time point 1, time point 2. Can we confidently say that they got better or worse, or that they stayed the same? And the way that we do that, we define that change as being real, is we use the error within the test. That might be natural variability that the athlete has, or systematic variability that the test generates. But if they jump outside of that error, then we say they got better. Alternatively, if, for example, they get worse and there's no overlap between these error bars, we say that they got worse. And there'll be plenty of examples where the error bars overlap, and really irrespective of what this trend line seems to be doing, we say that there's no change. It all falls within the error of the test. And we want to do that. We want to make sure that we have some way of defining a real change so that we don't make incorrect conclusions. And the way that we're going to do it here is using the standard deviation, and it means that we can report each athlete's score and say whether they got better or not. And to keep this brief, I'm going to direct you to this paper here, which explains the calculations behind it, the statistics behind it, the rationale behind it. And equally, once we have each athlete's score, we can rank them relative to their teammates, and that provides a fantastic reference point as to how well they're doing. And we're going to use Z-scores for that. So I've directed to this paper here, and both papers are available via this QR code here. So let's get to building this dashboard that helps us define whether an athlete is indeed improving or not, and how well they're doing relative to their teammates. So we've got the data set over here. We've got a group of athletes, and we've got 3 testing points per athlete. The first thing that we're going to want to do is turn this into a table. So click yes. Let's call this table CMJ. It's a jump-based table. And what we've got here now is their best score. So we're going to look at the variability. We're going to create our error bars because we take at least 2 trials. We've got the best score from that, and we've got the standard deviation as our measure of variability. And again, I'm using P because it's the population. I'm only looking to draw conclusions and apply these conclusions to my set of athletes. I have everyone that I'm interested in. If I was going to use this set of athletes to make an inference to another set of athletes at another club in another country, I would use .S, because now I would have a sample of the wider population to which I was going to make an inference to. But I'm using .P because I have my entire population. So there's our table. We can summarize this now with a pivot table. I'm going to keep it in the existing worksheet. We're going to use that table range there, new existing worksheet, and our location is fine. Oops, let me change that. Table, CMJ, existing worksheet, location. Let's put that over here. Fine. So how are we going to describe this data? So we want the filter. Our athlete is going to become our filter. The date is going to be by rows. We don't need this level of detail, so let's get rid of these. And then we're going to put CMJ best and the standard deviation to do our calculations. Now we are going to use max. We could use average actually, because there's only one value, so it doesn't really matter which one you use. So let's go max. It's looking good. We can get rid of these grand totals off the bottom there. That's not helping us out in any way. And then we're going to use these slices. We want one for athlete, one for date. So we can put these over here and another one over here. So now we start to be able to get the scores for each athlete from this table over here. And of course, we've got the different dates that we can look at as well. This one is just a multi-select. So I click on that, and now we can look at different dates. So we can compare 2 different dates. So let's put this into a figure. We'll put it into a line graph. And we're going to need to do that off of some separate data here. So here's our sheet here. Normally we would just cover it up, but underneath we've got where we're going to just pull the data from there, because in pivot charts you can't put the error bars in. So let me go ahead and create the data here, and actually I'm just going to type it in, because then I don't pull the code, if you like, from that pivot table. So a lot can go wrong when we start to do that. Let's do the same here. So now we've got J4, oops, J4 equals J5, and now equals K4 equals K5. Lovely. Right, I'm just going to make it clear, so I'm going to cover that over with the figures soon, but for now let's go in here, insert, we'll go line graph, let's bring that down, fit it in the space. So we don't need a title, we know exactly what it is. Go here, from the axes, if we just go to text only, we get our scores. Now we're going to want to add the error bars in. So naturally we want to do our custom, we want to specify that value. We're going for these ones over here. Oops, did I get that right? These, and then, yeah, same again. Okay, right, so now we can already start to see whether there's an overlap or not between the scores. But what we can do is put a verbal descriptor as well. So have they got better, worse, and so on, so forth. So for that we're going to use an if formula. So from here we're going to go equals if. Now what we want to do is to say whether someone got better or not is to look at where the error bars overlap or not, as the case may be. But let me make it a bit more obvious if we start here. So what we've got is if this value, the mean, and this standard deviation is less than this value minus this standard deviation, we know that they've got better. So let's go for it. Equals if. So there's master if this value here minus its standard deviation is greater than the mean over here plus this standard deviation, better put them in brackets over here, we can define that as better. And then of course we could do the opposite. So the opposite would be if this value here, so this is August 25th, this one here, minus this value here, its standard deviation, if this value, because now we're going to reverse it basically, was greater than this value here, which is March 25th, in the bracket again, so March 25th plus its standard deviation, then we would say, because now we've reversed it, we would say that they've got worse. And if none of those things happened, we would just say they stayed the same. So there we go. So this person has indeed got better. As we go across, that person's indeed got better. This person stayed the same. You can see there's a lot of overlap. Go towards the bottom. Yeah, this person has indeed got worse. And actually, we can go straight in. If we go to conditional formatting, we can go to text. So look, text that contains worse. That's already set up for us. Can be red. Let's go again. Text that contains better can be green, and then text that contains same can be yellow. So as we start to help provide those descriptors. Now, what we want to do then is provide the reference to the athlete's teammates. So here again, we want to look at the pull on the reference data. So here we go across to here equals that, and this equals this one over here. Great. So what we're going to do then is calculate the team average for that particular date, because we need the team's average and the team standard deviation to calculate a Z-score, because we compare the athlete's data to the team averages. So now to do that, we're going to use these formulas. So for the formulas that I've put in over here, because they're not so memorable, we go across. So as we go here, we have equals average, average ifs. Right, so we're going to try and calculate the average of the squad for a particular set of data at a particular date in time. And this is now where we use the table reference. So we go table, and there it is here. This is the table that we named. And if we do the square bracket, then what we can get is the best score, because that's what we want the average for. Click on that, close the bracket, and now we want to make that best score, the average of that best score relative to a particular date. So I need to go back into my table, which is just here, square bracket, and now we've got to get the date. There it is. And we just need to tell it what that date is, which is hidden over here, which is M23. Yeah, and there it is. And then we close that off. And there we have. So this is the squad's average during that period there. We go across to here because now we need the squad's standard deviation for that as well. So that's going to work ever so slightly different to calculate the standard deviation. So we get to here, so equals. So we've got standard deviation again. I'm going with the population. If, and of course on the worksheet you'll have these formulas written out for you. So I want my table. There's the table. Now for this one we need to identify what the date is. Close that off. I can see the cell I need to highlight this time. There it is. Now I want to tell it for the metric, and that's going to be for the best, and I need to tell it that that's within that table. And best, CMJ best. There we go. So now we have the standard deviation. we go across again for the Z score now, so if you remember from a Z score, quite simply works out to be the athlete score. So if we go here, this is the athlete score. Oops, need to add the equals in. So it's the athlete score minus the squad score divided by the squad standard deviation. And that's our Z score. And you know by the interpretation of that Z score infers it's above the average. And now to get that as a rank, because maybe that's more intuitive to interpret, we have this norm as distribution. So it's going to tell us where it is within a normal distribution. So equals norm S dist. We want the Z score, which is hidden. So P23. Yep. True. If I times by 100, I get it as a percentage. And there we go. And again, on the worksheet that you can download this worksheet from here. You can see the relevant equations. So again, we need to repeat as we go across to see how they progress. I'm just going to keep it brief. I'm not going to do the other side. If we go here, we've got conditional formatting. We can do some highlight rules as well. We can say, as is a percentage, we can say that greater than, let's say, 66. Let's make that green. Okay, let's go here. Highlight rules. Let's go less than 33. Let's call that red. And then of course, let's go in between that, between 33, 66, and let's just say that's no change. So again, as we then start to look at the athletes, and again to point, you've got these formulas here. Let's go up. Let's cover this. This should be what you end up with.